The sound is very important. Right now, the plastic cover on the back. Okay, listen to the sound. The sides are not snapped in all the way. This is actually not on tight enough to set the time. The sides snap in. And there's 2 screws. Okay, we're back to running. See it go? Now there's a galloping sound and I haven't done anything. I think that's a problem. I'm going to push this side in some. Okay, you can see it's running and you may still hear this kind of galloping sound, but we'll let it go for a while. See, maybe at least an hour probably, and then see about pressing in the other side a bit. Okay, tighten screw on lower right, and still got a kind of a giddy up sound. See if it keeps running. I'm leaving the other side not snapped in yet. Step at a time. It also was running very fast yesterday. I've got it about as slow as it can go, and it's actually running just a touch slow, I think. Still sounds okay. Still running. Still sounds pretty good. It was running a little slow, so I slightly sped up the rate. Adjusted that, and now we're going to gently tighten the screw on the back because we are snapped in both sides. This screw is already tightened, and I'm going to tighten this, but not hard. Okay, let's see how it sounds. Not really hearing the galloping now. I'll mention I did put some WD-40 in the first day also. And again, the battery's kind of hanging in there. If this is still running at lunchtime, I'll snap on the back, which is this thing. Hope for the best. Okay, this is the latest installment in the clock repair. It turned out that it was drawing would eat batteries in just a day or so, a whole D cell, and it was running a little slow on the highest speed. So I did a couple things. I took a Dremel to the gear that tensions the spring to change the speed, so I could turn it just a little bit higher. You can see there's no battery. And then you can watch the motor turn. I found this, well, it will reduce DC voltage. You can input from 5 to 36 volts, and you can dial it down between 1 1/4 to 32. And I've done 2 things. One, I ran this to the plus and minus of the battery. That is fed by the output of this device, and you have to be sure you've got the plus and minus correct. So it's DC, and it's nominally 9 volt 200 milliamps. So I set it up, I'll plug it back in. So right now it looks like it's reading 1.44 volts out. So you may see a red light flash. That's just telling us that it's trying to draw just a little bit. The clock's trying to draw just a little bit more. I measured the clock at about 6 ohms. Realizing those motors and stuff, that's not the best way to figure out. But that does put you at about a quarter of an amp for 1.5 volts. Right, 1.5 divided by 6, 0.25. So you can see it, the red light flash sometimes. I kept dialing down the current limiter until I started tripping the current limiter. And I think that's safe. So, of course, because as the battery goes dead, it's going to supply even less current, no matter what you try to do, because the voltage keeps dropping. So here we are reading 0.24 amps. And that's the draw. Remember, the wall wart says it's a 200 milliamp. So I'm at 0.2. So the red light will come on, show that it's limiting current sometimes. I suppose I could dial the voltage down a little bit. So 14 in, 1.21 out, it's saying now. So I will turn that up just a smidge. So that's what I think it does to limit current, is it actually limits the voltage. The clock is now running off this buck converter, again, which knocks down DC voltage from whatever source you got. I'm using this wall wart. And we'll just keep an eye out to make sure it doesn't get super hot. That will keep the clock running without needing batteries. Instructions. We had to assemble the case, and everything seems to be working.